Okay, we are starting up our lesson on statistics. This is our first lesson, part 1, measures of central tendency. Let's see what we got going. So first of all, let's talk about what statistics is. You don't have to write down this slide, but the process, it's basically the process of asking a question, gathering data to answer that question, organizing and representing the data in things like tables and whatnot, and then describing or analyzing that data so that finally we can use that to make predictions or draw conclusions. So just when would we use statistics is a question that pops up a lot, of course. I mean, sports, so I put baseball down here example. If you look on the back of a baseball card, you see all the statistics about that player, and you can make a prediction about what he might be like. Statistics is a type of math that's used heavily in humanities, which is social sciences, things like psychology, sociology, whatnot. Anytime whenever you need to gather information about a bunch of people or populations so that you can make a conclusion about what people or populations are most likely going to do. So what we're going to learn in this lesson is how to represent our data using a stem and leaf plot and how to interpret a histogram. And then finally we'll look at measures of central tendency. What that means is what number best represents an average amount. So there's 3 ways you can find that. It's with a mean, a median, or a mode. Alright, well first of all, when you do this slide, you only need to get down the definition. You don't need to write down the examples. We're going to do a few of those later. This is what we call a frequency distribution. It's a table that shows how often a certain event occurs. So over here, as you can see, oops, let me go back a little bit. On the left side of our table, we have test scores. Somebody got a 99. In fact, 2 people got a 99. For the score of 97, looks like 3 people got that. For 88, 4 people. So on and so forth. So basically, the score goes on the left, and the frequency, how many times that happens, goes on the right. This is really only really helpful whenever you have a lot of repeats. Another way you can make a frequency distribution is by looking at a range of scores. Instead of just a score of 99, you could look at something from 90 to 99, and we'll do a few like that later. Alright, a histogram, once again, just the definition and word is necessary here. A histogram is the bar graph, so to speak, of a frequency distribution. So it's basically just a graphical representation of what we had over here in the frequency distribution. So for example, in the score range from 70 to 74, there was 5 scores, and that's also over here in our frequency distribution. From the score range of 80 to 84, it looks like there was 1, so our bar only goes up to 1. So on and so forth. Now, if we don't use anything below a certain point to 0, we just put a squiggly mark because we don't have anything below 70 to record, so we just put a squiggly mark there. And that's what we call a histogram. Another way we can represent data is with something called a stem and leaf plot. Basically how this works is we put the digits that are in the ones place on the right, and then we put all the other digits to the left of a bar. So for example here, 70. I've got 5 scores of 70. So I'm going to put the tens number, which is 7, on the left, and to the right I'm going to put 0 5 times. And what this represents is 70 5 times. Likewise for the scores of 80, I have an 80, so I've got 80, but I've also got 4 88s, so I've got 88, 88, 88, and 88. And then for 97, I've got 3 of those, so notice I haven't, for my 90s I have 3 7s, and then for the 99 I've got 2 of those, so under my 90s I also have 2 9s. Alright, so let's do an example problem. We're going to use this data below to make a stem and leaf plot. Alright, so to make a stem and leaf plot, first of all I'm going to just draw a vertical line, and then I'm going to put all the tens digits that I have here. I'm going to start with the biggest one first. I've got 30s, right? And then I have some 20s. I've also got some teen numbers here. And then I've got numbers that are simply a ones place. You could just put a 0 for those because they don't have a tens digit, they're just ones. Alright, so starting with the ones places, I have 2 5s, right? So that's those. As for the tens, I have 2 16s, so I'm going to put 6 and then 6. And then for the 20s, I've got 3 23s, so I'm going to put 3, 3, and 3. And then for the 30s, I've got 2 38s and a 39, so I'm going to have 38, 38, and then 39. And that pretty much covers it. The purpose of any way of representing data is really just to take a long strand of numbers that might look meaningless and group them in a way that looks more meaningful because they're grouped in a way that makes sense to us. So these are grouped by tens, as you can see. Alright, now for example 2, this gets a little bit more involved. We're going to do two things. We're going to make a frequency distribution, and then notice it says that we're going to use 5 intervals. So what do I mean by that? We'll see when we get there. And then after that, we're going to use our frequency distribution to make a histogram. So how do we make a frequency distribution? Well, this is an awful lot of information. We could just go by who got a score of 1, who got a score of 2, and then 3, and put that in each one. But what I'm going to go is I'm going to go for 5 intervals. So I want to break up all this data into 5 groups, basically. That's what it means by 5 intervals. So, well, how do I do that? The first thing we're going to do is look at your range. The scores go from 1 to 10, right? So the range, to find that, we'll talk more about that even in our second lesson, but the range is basically your high minus your low. So my highest score is a 10, my lowest score is a 1, so I'm looking at a range of 9, right? Now I want to break 9 up into 5 groups. So what I'm going to do is I'm going to divide 9 by 5. Now that's not going to give me a nice number, is it? 5 goes into 9 one time with 4 left over, which is 4/5, so you got about 1.8. So what we'll do is we'll just round it up to the nearest whole number, 2. And so basically what that means is in our frequency distribution, numbers are, each category is going to be in groups of 2. So let me show you what that looks like. So my first set of scores are going to be going from 1 to 2. Right? My next scores will be going at what comes after 2 is 3. So those will be going from 3 to 4. And then after that, 5 to 6, 7 to 8, and 9 to 10. And as you can see, by doing this, I've got 1, 2, 3, 4, 5 groups. So I've taken all the possible scores, it's 1 through 10 basically, and I've broken it up into 5 equally spaced groups. Once again, you do that by subtracting the high number from the low, dividing it by 5, and rounding that to the nearest whole number, and that's going to get you your groups. Okay? So we'll call this the score column. And over here we'll call this the frequency column. In other words, how many scores fall under these categories. So how many people scored 1 or 2? Well, as we can see up here, there's 1, 2, 3, 4, 5 people scored a 1 or 2. So I'm going to put a 5 right here. How many people scored a 3 or 4? That's the next category. 1, 2, 3, 4, 5, 6 people scored a 3 or a 4. 5 or 6, we have 1, 2, 3, 4, 5, 6, 7. 7 or 8, we have 5 scores. And for the 9s and 10s, we have only 3. Alright, so there's our frequency distribution, but it's one that's been not just by one score at a time, but groups of scores. And specifically, we broke it up into 5 groups. 5 is a pretty good number. You're welcome to break your data up into any number of groups you want, but as a general rule of thumb, 5 is a pretty solid number of groups to have. It gives you a pretty good spread. Once you start going too far past 5, you've got too much information and it's kind of overwhelming. Anything below 5 is kind of not telling you enough information. So 5 is a pretty sweet number to use when you're looking at how many intervals to use. Alright, well, that all being said, we're ready to make our histogram. So as we do this, we got to keep in mind our groups and our frequencies. So we start off with this little L bracket form. So for my first group, it goes from a score of 1 to 2. I like to put the starting amount for each group on there. So my first group starts with a 1. The next group starts with a 3. The next group starts with a 5. The next group starts with a 7. And my last group starts with a 9. And we'll go ahead and take that up to 11. Even though we don't have any scores of 11, our bars are going to be extending from 9 up to, but not including 11, so we're going to put the 11 marker in there. Alright, now, so that takes care of my scores. The scores go on the horizontal axis. Now the frequency goes on this side. So, as you can see, my highest frequency is a 7. So I need 7 marks up, evenly spaced. Alright, so here we go. So for my first group of scores of 1 to 2, I've got 5. So I'm going to climb up to 5 marks. Go over and down. For my next group, 3 to 4, we go up to 6. For my next group, 5 to 6, we go up to 7. Notice how they're touching each other. The reason for that is because the data is continuous. Where one leaves off, the other one picks up. So for scores from 7 to 8, we have 5 scores, and for scores from 9 to 10, we have 3. So we're only going to go up 3 high on this one. Okay, so there's our final solution there. We have our frequency distribution over here on the left and a graphical way of representing that on the right over here. Once again, the stem and leaf plot, the frequency distribution, and the histogram are all ways just to represent a meaningless strand of numbers into groups so that we can quickly assess what's going on. So, let you guys go ahead and take a look at a quick example here for you to try. So you might want to pause the video, try these 2 questions for this data set below. Pause it, and then we'll move on to the answer in just a moment. So this would be the solution you got if you did those 2 things, the stem and leaf plot on the left and the answer on the right.